Hi, this is Miss Nikki. Let's talk about some Chapter 2 concepts. The thing to focus on here are some of the basic definitions. What's an element? It's any substance that cannot be broken down into a simpler substance. And we have some of the 6 elements of life over here. So these are necessary for life. Some people call this chanops. An atom, this is the smallest unit of an element. Every element has an atomic symbol, and we're showing you here the atomic symbols for these 6 elements. Okay, these are subatomic, so inside an atom. So this is showing you an atom. That's what this whole thing is here. And inside an atom we have electrons, we have protons, and we have neutrons. Neutrons are neutral. Protons are positive and electrons are negative. So here is the element carbon, and here is its letter designation. Here's its atomic mass, and here's its atomic number. What this means is that 6 atomic number tells you how many protons, always. So this is atomic number. Electrons are usually equal to protons. So if you have 6 positive things, you're probably going to have 6 negative to balance out this atom. And there are exceptions to this. I'm being very general. Neutrons, you take your atomic mass and you subtract it from your atomic number, and that gives you neutrons. So we can see there are 6 protons, because that's what this atomic number says, right? We know if there are 6 protons, there should be 6 electrons. 1, 2, 3, 4, 5, 6. And then if my atomic mass is 12 and my atomic number is 6, then that means I have 6 neutrons. It's not always the same. It's not always the same number for all of them. It does change and vary. There is something called isotopes. Now, isotopes are where the atomic mass is slightly more than it is normally. So this is our normal carbon. Sometimes the atomic mass will find carbon atoms that have a higher mass. So they have the same number of protons, but they have different mass numbers. And remember, what does the mass number tell you? 13 minus 6 would tell you you have 7 neutrons. What's 14 minus 6? That would tell you you have 8 neutrons. I spelled that wrong. That's funny. Okay. So what's an isotope? It's an element with varied number of neutrons. One of the things I want to point out is that the proton number has to always stay the same. So 6 is carbon, 6 is carbon, 6 is carbon. If the proton number changes, it's no longer carbon. And probably the best way to look at that is the periodic table. So here is the atomic number, that's carbon. Well, what happens if so this is 6 protons, right? What happens if I have 7 protons? I am no longer carbon, I'm now nitrogen. What happens if I have 8 protons? I'm now oxygen. Okay, let's look at this octet rule, but before we do that, let's look at the structure of atoms, right? So these are all atoms. Excuse me. So here is hydrogen. It has a mass of 1, and it has a atomic number of 1. So atomic number means protons, so it has 1 proton. That means it has 1 electron, and the mass right here is 1. So what was mass? Mass, if you took, that was the number 1, if you took 1 and you subtracted it from the protons, it would tell you neutrons. I keep doing that today. Neutrons. There we go. So this has 1 proton and 1 electron. Let's just do a couple more to make sure we understand. So this is the mass, and this is the atomic number. So there's 6 protons, there's 6 electrons, and 12 minus 6 is 6, so there are 6 neutrons. All right, let's look at this octet rule in the rings. So the first shell, there's something called an electron shell. That's the area in which electrons are most likely found. There's a shell, first shell, and it holds 2 electrons. This second shell holds up to 8 electrons. So octet for 8, right? So the first two electrons fill into the first shell. So remember, stop it. We have 6 protons on the inside. We have 6 electrons. Electron 1 fills here, then 2 fills here. Then the 3rd, 4th, 5th, and 6th fill. Nitrogen is 7. So there are 7 protons, and there should be 7 electrons. 1, 2, 3, 4, 5, 6, 7. 8. So this should be 8 electrons, right? 1, 2, 3, 4, 5, 6, 7, and 8. But what we need to pay attention to is this outer ring. The outer ring wants 8 electrons in order to be stable. So let's look at oxygen. Okay, so this inner ring has 2 electrons. The outer ring has 3 and 3, so it has 6 electrons. We know that 2 plus 6 is 8. We know that this is the same as our proton number or electron number. But what I want you to see is this outer ring, I said it can hold up to 8, right? Holds 8 electrons. How many are in the outer ring? There's only 6 right now. So 8 minus 6 means there's room for 2 more. So 6 electrons here, I can add 2 more electrons to get to my 8. What this tells you, this octet rule, and sometimes they'll call this valence shell electrons. If it's filled with 8, it's not reactive. If it's less than 8, it will react when it bumps into other atoms. So oxygen loves to bind 2 items. It needs or wants 8 in its valence electron, so it will bump into and react with other molecules. So what about carbon? There are 4 electrons. It wants 8, so there's 4 needed or wanted, however you want to word that. What about nitrogen? There's 7, but there's 2 here, and then there's 1, 2, 3, 4, 5. So there's 5 in the outer. It wants 8. That's a remainder of 3. So it's looking for 3. So what will happen when we talk about reactivity, again, this is the first shell, it holds 2. This is the second shell, it holds 8. Third and up holds 8 as well. So this is a sodium atom, and you can see it has 1, 2, and then it has a full 8, and now in its third ring it has 1 electron. I guess I shouldn't draw the plus yet, it's just sodium. Okay, so it has 1 electron. It can either add 7 or it can give up its 1 electron. If it gives up its 1 electron, now its outer shell has 8, so it's happy. So in this example, when you have molecules, or in this case atoms, that come together to form a molecule, you can see this sodium, it's much easier to give up 1 electron so that its outer can be 8. With the chlorine, do you see how chlorine has 1, 2, 3, 4, 5, 6, 7? It's missing 1 electron right here. So the sodium gives up its electron. Now the chlorine has 8 in its outer shell, so it's happy. So I'll draw in my little 8th electron. When we do this, when we give up electrons or we gain electrons, we now call them ions, and they're charged. The overall atom changes. Remember, okay, so the inside is still positive. We have our protons on the inside, right? You can go back and count up the electrons to figure out the protons if you want. So there's 1, 2, and then 8, that's 10, that's 11. So there are 11 protons inside the sodium atom. And now there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. That should make sense because we gave 1 electron up. So if I have 11 positive things and I have 10 negative things, that makes me overall slightly positive. Now what did the chlorine atom do? It took on an extra electron, and that electron is negative. So the overall chlorine atom now becomes chloride, and it is negative. So when these atoms come together, they will transfer their electrons, but because they're positive and negative, it keeps them in close contact with each other. So here's an example of covalent bonds. This was an example of ionic bonds. If I transfer an electron, I'm an ionic bond. Covalent bonds share electrons. So this hydrogen is positive on the inside, and it has 1 electron and 1 electron. But remember, this first shell wants 2 electrons. That's what it wants. If they share those 2 electrons, then they both have 2. Look at oxygen. Oxygen, we can go back if you want. What do we say about oxygen? It has 6 in its outer shell. It wants 2 electrons to get to its 8. So these 2 come from this oxygen, these 2 come from this oxygen, but they're sharing all 4. So if they're sharing, that's 4, 5, 6, 7, 8. They each have 8 in their outer shell. Look at carbon. Carbon wanted to bind with 4 items, right? It has 4 electrons, places that can hold in that outer ring. So here's the 2. This one was carbon, this one was carbon, this one was carbon, this one was carbon, right? So carbon had 6 electrons. Well, this is the electron for hydrogen, and this is hydrogen's electron, and this one, and this one. So you have 4 hydrogen electrons. I'll write it like that. Sharing with the carbon atom. Why does this make everybody happy? These 2 give this outer shell 2 electrons. That's what it wants, right? That's that first shell. 2, 2, 2. Now look at carbon. 2, 2, 2, and 2 for a total of 8. So this is why we also have water, which we'll see in just a second. Oxygen wants to bind to 2 other items, and the hydrogens are going to share electrons with the oxygen. And here's our beautiful picture. I didn't need to draw it, right? So 1, 2, 3, 4, 5, 6, 7, 8. There's 8 in oxygen, 8 electrons in oxygen's outer ring or shell, which it wants. And hydrogen has 2. And remember, that first shell only wants 2. So this is why water forms. Now, specifically, we're going to talk about how hydrogen bonds form. So this is just one molecule, right, of water. Well, what happens is that the oxygen is overall negative on this side. So it's slightly negative on this side. Remember, there's a positive proton here, so this side is slightly more positive, and that's what they're trying to show you here and here. So if let me switch colors, get to black. So if this is, oh, come on. If this is negative and this is positive, this is negative, positive, negative, positive, negative. I'll just do a couple. So the negative oxygen is attracted to the positive hydrogen. and the negative oxygen to the positive hydrogen, and the negative oxygen to the positive hydrogen. We call those hydrogen bonds. Properties of water is the next topic we need to discuss. So first two things, cohesion and adhesion. So when we talk about adhesion, we're talking about water molecules sticking to the surface of something. Cohesion is the fact that water molecules like to stick together. You need both of these properties. You need the water molecules to stick together, and then you need the water molecules to stick to the surfaces so that you can help draw water molecules through an organism like a plant. Also, like us, when we talk about our blood vessels, this is how we transport fluid. Remember, our blood is mostly water. Another property of water is that it absorbs and releases heat slowly. When water changes from a liquid to a gas, it releases heat. I'll show you a picture in just a second, but let me first explain the density of water as well. And this will, when we talk about ice, this will help with the next example. You see this ice lattice? If this is liquid water, do you see how they're all jammed together into a droplet? This is because of cohesion and adhesion, right? Then when it freezes, when you freeze water, it forms these nice ring-like structures. It's a property of water. And this, you see how they're all spread out. They're even and they're spread out over a larger surface area. So this floats. So ice will float. It is less dense. So they're trying to show you here the ice layer. So this is the ice and it's floating. And let's say we have the sun over here and the sun is shining on the water. So during the day, the water temperature rises slowly, daytime, and at nighttime, the temperature drops slowly. So what would happen if this ice was really thick and dense? If it was thick and dense or heavy, what would happen to the ice? It would drop to the bottom. And then the next layer would freeze and it would drop to the bottom. And this would continue to happen until all of this was frozen. This is not good for life, right? Very few organisms can live in this kind of environment. The example with the sun, the reason that we talk about this property of water is because with this temperature difference. So they're saying that as the temperature increases during the daytime, the water warms slowly. And then at nighttime, it cools slowly. What would happen if the ocean was boiling at noon and it was frozen solid at midnight? You would not be able to sustain life, or there'd be very few organisms that could live in that harsh environment. This one is probably one of the most important, and it's the fact that water is a solvent. Basically, if you put an item in water, the water molecules will pull that atom or molecule apart. So here is our sodium and our chloride. We can think of it as salt. And you can see, remember how the hydrogens are positive and the oxygens are negative, and they're usually interacting with other water molecules by hydrogen bonding. But what will happen is that this molecule that was closely together, the water molecules wedge themselves in, and this is positive, so it gets pulled apart by the oxygen from the chlorine. And you'll have these water molecules surrounding these ions as they're being pulled apart. So basically, solvent you can think of dissolve. That leads us to this acid, base, and pH scale. So let me go to the next slide and then I'll come back. Here's our water. Here's our water. And they're saying that water will sometimes break, and sometimes you'll have OHs and sometimes you'll have hydrogens. So let's say this molecule broke here. This hydrogen goes over here. These two come over here. So occasionally water will disassociate from itself. But let's say we add one of these items to a beaker, what happens, the water molecules again are going to try and pull apart the molecules. So this would be positive and this would be negative, and they're in association with each other. And the water molecules wedge themselves between these two and they get split apart. Again, here's water, and we have a sodium hydroxide this time. So here's the hydroxide, here's the sodium. Water is going to wedge itself between the two and split them apart. So back to acids and bases. This is the neutral line, and 7 is neutral, pure water, tears. You can see milk is close and blood is close. They're within this narrow range of what's neutral. Acidic means, and here's our hydrochloric acid example, acidic means if I drop it into water, what am I going to release? You're going to release lots of these. Sodium hydroxide, if I drop this in water and it gets split, I'm going to release lots of OH negatives or hydroxide ions. So if you drop any of these items in water, you're going to get out lots of H pluses. If you drop any of these, you're going to get lots of OHs. We call that basic, and we call that solution acidic. So lemon juice is acidic, but vinegar is less acidic. So this is most, and this is least. This is, that should be down here, most basic, and this is least basic. Okay, well that's the end of chapter 2. I'll see you guys for chapter 3.